So how was the assignment? Are you all okay with it?
Hocam, we did something, but we are not sure that is it true or not.
Okay. And Wahab is the representative of all people in the class?
Sorry, hocam, I couldn't understand you.
I'm asking why other people are not talking.
I don't know why, really.
Aren't you the representative? Okay. Okay, it looks okay. We're gonna continue. Like I just checked a couple of people's assignments and it seems okay. We're gonna continue tomorrow with Linux actually. And there is one more part I want to show you that would be tomorrow in the lab. Did you also try, guys, you need to talk, by the way, then if you are nice to me, I will be nice to you. And being nice means talking in the Zoom for now. So this is a threat also. Did you try to install Python to your computers?
Yes.
Did it work?
Yes, yes.
Okay, who is talking?
Defne.
Defne. What about the rest of the, did you try idle also, guys?
Yes, mine idle also working.
Okay, and you installed 3.7 or later, right?
I think it's 3.9, something like that.
That is cool.
Okay.
So let me know, like try idle also. That data camp tutorial will help. You have that link for Python idle. So go there and try to install it. This week also, we will probably not use it, but starting with next week, we're gonna start to that Python part. Okay. Now I'm gonna start to programming on the parallel, but tomorrow we will be like going back. And normally we will do the lab session in person and on Fridays, and this will be like this on Thursdays. And let me see, share my screen. Okay, guys. So, do you see the slides?
Yes.
Good. Somebody else talked also. Wahab got, because I told him like, this is ugly when I'm the only one. He got the message. Okay, guys.
Ben ağzım yandığı için hocam yoğurdu üfleyerek yiyorum.
I need to do the same thing to everybody.
Teacher, can I ask something?
Who is talking? Can I see some of your faces if it is okay, guys? Like this is awkward. If you become a teacher, like it is like talking to the wall. So if you can open your cameras, that would be nice. No,
I'm Nisu.
Did you hear
where
right?
can-
The rest of the class?
Where can I find the link for download Python?
It is on your syllabus.
Okay, thank you.
Here, let's see. Do you see like, you have it, this data camp link here, the second one? It will tell you the instructions one by one.
Okay.
Tamam. Az önce söylediğim şeye ne oldu? Kamera açma hikayemiz. Ben de siz soru sorduğunuzda böyle mute kalacağım gençler. Bu bir karşılıklı şey, onu unutmayın. The biggest problem in our country is not mine, yours also, is not talking. Like this is the first thing that we are learning in the university actually. It is an interactive, it should be. This is your last chance of learning stuff. And that is the major problem probably. You are not talking in the high schools. Heh, Defne bu kadar şeyden sonra bitti. Biriniz açın en azından.
Saçımı düzeltmeye çalışıyordum. Yeni uyandım da.
Hepimiz aynı şekilde. Siz şeyde benimki de düzgün değildir. Ha, varmış aşağıda birileri açmış. Ben görmüyormuşum galiba, öyle mi? Beyza, Esra, you are in the lecture. You were in the lecture since the beginning.
No, I am at home hocam.
Hayır. I see that. But you were taking this lecture last week also. I didn't see you in the class or online, right?
I am at class hocam. I was at class.
Yeah, but you didn't come to the university.
I did.
Did I see you?
Yes.
I remember you before even you came to talk to us, right? Like before you when you were passing from.
Yeah, yeah. For passing the proficiency exam.
And okay. I didn't see Beyza, were you in the lecture?
Yes, teacher.
Hiç görmemişim ben sizi gençler, neyse. For tomorrow also, you don't have to attend, but you can attend. And tomorrow we're gonna do the last part of the Linux. So if you don't have a Mac, it would be an issue if you are not attending the class. Okay. So the last one is Python tutor. We're gonna use that one also. It is something you're gonna see that like when we write our codes, we can visualize them in there, and it shows how the execution of the program step by step. So it will be helpful. The last one, the Python tutor. Okay. Now, what is programming? We're gonna start in paper today. And for those of you who took Core KHAS 109, the beginning will be like a repeat, but that is still good. You will get more chance to digest what you learned. So bear with me for the beginning part, okay? Now, what is programming? Programmer wants to solve a problem in a systematic way. It can be any problem. Washing clothes using washing machine or finding the largest number in a list of numbers. They are both problems. So it can be for a programmer, it can be both these type of problems to solve. So for instance, let's think about this. If somebody have never washed their clothes in a washing machine, how would you describe to them? And if they are not from if they have zero experience with the washing machine, what would you tell them? What is the first step? What should they do?
Hocam, I have also zero experience.
Who is that?
Esra hocam.
Çok iyi cevap da biraz okay, describe it to Esra then.
It would be great.
Huh?
Anybody says it will be great hocam.
Okay, let's see then. Who washed clothes before? Şimdi hepsi biz hiç çıkamadık hocam falan diyecekler.
First we take the code
Huh?
and put inside.
Okay. Put
First-
the open the lid, right? Load the laundry, Wahab is saying, right? Then hocam sabah sabah kalktık çamaşır yıkayacağım. Benim için de sabah, unutmayın, benim için derken. Load the laundry. Then böyle otururuz sessiz. They're gonna need to do something with the detergent. Add detergent and additive. Next.
Start button hocam.
Is there a single button? You don't pick any.
Oh, okay. We choose a program.
But how will I choose the program? No, I mean There are different temperatures. There are different.
There are a lot of options. Yes, temperature, water.
Okay. So you need to give description. Switch the machine on. If clothes are wool, select. This is a simple binary system again, but if clothes are wool, select a wool program. Otherwise, select a normal program. After picking the correct program, then start the program. Wait until it is done and remove the clothes. Okay, so you need to be specific, like about the steps. And this is an algorithm. This is abstract, detailed computing instructions that solves the problem. Mainly, algorithm is the recipe to solve a problem, but you need to be clear in the steps. And we're going to give these descriptions to computers also, okay? So a recipe like this is an algorithm. And all these sentences, if, otherwise, start, wait, for instance, we're going to use those in the programming also directly, okay? So there is the algorithm, then we will go to the programming language, but we are not there yet. And the hardest thing for you will be in the beginning, algorithm part, okay? Even like you will learn the language, but at the same time, you need to think about the solution also. Algorithm is not the language. Algorithm is this how you're gonna write, like how you're gonna solve that problem. So today, let's try to go over that first. And by the way, you will get used to the algorithms also. There are different algorithms. You will get used to the algorithms with time. Like when you write more programs, you will feel familiar with like what type of algorithm you're gonna use, okay? So it doesn't come in the beginning, it will be a little hard. Another problem is finding the maximum number in a list. Now, if I give you this list of numbers, let me actually wait. Okay, what is your, like, when you look to these numbers, how you find the maximum number on the list? What is your brain doing? What are you doing right now, for instance? What is the biggest number in this list?
I'm scanning, hocam. Scanning.
Okay,
Trying to find
yeah, what is the largest number?
199.
99, yeah.
199, right? But how your brain, like we do these things automatically, right? You generally don't notice what you are doing, but how did your brain process this problem?
While scanning, I'm like kind of only taking the biggest number, and then, for example, I'm comparing 5 and 6, and 6 is bigger, and then I'm taking 6 and then comparing it with 9, and 9 is bigger, so I'm taking 9 and like that.
Okay, Defne, if you try to describe this,
Şey, you are muted, huh?
To another person, if you try to describe this to
Hocam,
somebody who doesn't know how to find the maximum number in the list, how will you do that?
I don't know.
But you just describe it to me, right?
Yes, but
So try to generalize that. Instead of you comparing 5 and 6, what are you doing actually?
Hocam, we can compare the two numbers and eliminate the little one, small one.
Okay, so who is talking?
Çağla.
Çağla.
Hocam kameramda bir sıkıntı var. Çok özür dilerim. O yüzden açamıyorum.
You are comparing what you, if somebody doesn't know, like you just give them the list and they don't know what to do. You're gonna say, take the first two numbers. Am I right?
Yes.
Then compare those two numbers.
Yes.
Then what is next?
Then eliminate the smaller one.
Eliminate the smaller one. Should I write it? Like, let's see. Okay. let's see whether it's gonna work. So what are we saying? Read first, and let me say second number. Okay. Then
Compare them.
compare them. Next step,
Eliminate the smaller one.
Nate.
you are going from the negative side. How is your brain eliminating? What do
That
you,
one is bigger than this.
yeah,
Right?
but when you say eliminate the smaller number, what does that mean in your brain? Defne was saying, like, I'm keeping the larger one, right? You are keeping that number in your memory mainly, the larger one. So eliminating means deleting from the memory, actually, in terms of the computer. Do you see that?
Or we can say keep the bigger one.
Mhm. Keep the bigger one, let's say. Now, let's look at to the numbers and let's look at to the recipe. This is our algorithm. Read the first and second number, 5 and 6. I read them. Compare them. Is 5 smaller than 6? No, I'm going to keep the bigger one. 6, keep the bigger one. What is next now?
We will compare 6 and 9 now.
Okay, but how will I say that?
Compare the next two numbers, we can say.
Read second and third number.
Yes.
Let me put it that way. Read second and third number. Compare them. Keep the bigger one, you are saying, right? Right?
Mhm.
Then, now I compare 6 and 9. I'm going to keep 9.
Mhm.
The next step,
Same step for next one, 9 and 13.
yeah, but how will I say that to the person? We don't know, like it can be any list maybe, and we don't know, should I say third and fourth number?
Yes.
Compare them, keep the bigger one. Now, an algorithm, a recipe should work for any input, okay? For instance, for the laundry case, it should have worked for any laundry. Like if it is wool, it will work. If it is not wool, it would still work. Let me change the order. Now, you said read the first and second number, 6 and 5. Compare them. I did. Keep the bigger one. I keep 6 in my mind, right? But now you are saying read the second and third number. Now I am reading 5 and 9, right?
Mhm.
And I'm going to compare them. I'm going to keep 9. Okay. What if I put will this algorithm work for the problem here?
System gives error hocam.
No.
Why? Because we are making a mistake, right? Read the first and second number. I did that. I keep the bigger one, 232. But then I'm reading second and third number. Those are
Not second, but we need to read the biggest number and the third number.
so when I say keep the bigger one, let me put it as a new variable. I shouldn't say variable, but in my head, there is a max, okay? Maximum number, the largest number. So I'm gonna keep that number in my head. Then I am gonna go to the next number, okay? So instead of here, if I put something like this, and if I can remember, okay, let's read Read the first and second number. 232 and 5, right? Compare them. Which one is larger?
First one.
First one. So what is my max at this point?
232.
That is what I'm keeping in the memory. Okay. I eliminate 5 now. Now I'm going to read the next number. Next number is 9. Am I right? Yes.
Mhm.
I'm going to compare them. Then 9 and 232. Which number will I keep?
The maximum, like the.
I'm not going to
232.
change the max. It will be
No.
still 232. Then I'm coming to here, comparing them. Do you see, like, there is a redundancy? By redundancy, I mean compare them, keep the bigger one. These are repeating themselves. So I can write this in a more compact form. There's a repeat in this thing, right?
Yes, hocam.
Let me... And let's write it, yeah, the first number, then read the second number. Let's separate them into 2 steps. Read the compare them, keep the bigger one as a max, read the next number. Şimdi ben de şu an şu algoritmayla çözemiyorum şu haliyle. This is step 1. Okay, and this is step 2. Then I have a step 3. Step 4. And do you see, this step is same as this one, right? I can just say, instead of repeating myself, go to step 2, right? Read the next number, compare them. I'm going to compare with what? Let's see. Compare current number with your max. Okay, now let's see that there's still an issue, but for the first step, compare current 2 numbers. Current, it's not working for the first step. Compare the first number and the next number, we said. Now let's see what will it complain about. We are trying to think like a computer. By the way, we are not trying to think like a computer. We are trying to teach the computer how to do this. I read the first number, 232. The next number is 5. Compare current number with your max. Now, what is my max? Do I have any max in my head?
Yes, 233 hocam.
No, I didn't. Do you see? In the next step, keep the bigger one as max. So I don't have a max yet.
Oh, okay.
Compare current Keep the bigger one as a max. Now go to step 2, right? I came to here. I'm keeping max as 232 and I want to do this step in a loop. Read the next number. 9 is the next number, right? Now what I'm saying is compare numbers in 1 and 2. Oh, sorry. Now what is the number in the first step, first one? It is still 232. So this is not working because I'm not updating the numbers. Let me show you another example, for instance. Here is another algorithm. Read the first number. Let's see that. Okay, what is our first number?
5.
5.
Next number in the list? 6. Compare the first number and next number. 5 and 6. Keep larger one as your max. And that is 6, right? Now go to step 2. In the step 2, which number will I read? When I go back to here?
9.
9. Compare first number and next number. I will be still comparing 5 and 9. Okay, because my first number was 5. Now my next number is 9. So I'm going to compare 5 and 9. Right?
But there's a problem, right, Hocam? Because we compare the first one.
Yeah, I will always be comparing the first number. So this algorithm will not work. How can I correct that? Let's see. Read the first number in the list. That is
5.
okay. Now the trick is set your maximum number to the first number. So right now, your brain says 5 is my maximum. Okay, I'm gonna keep that. Read the next number in the list. What is that number?
6.
6. Compare your max. What is our max?
6 now. 5, normally 5, yeah.
Okay, it is 5. And what I'm saying is compare your max to the number in step 3, which is 6, right? Keep larger number as your max. So I'm changing max to the 6. Then I'm go to step 3. Which one is step 3? Here. Okay. Now read the next number in the list. What is the next number in the list?
9.
Compare your max. What is my max at this point?
6.
6. And the number in step 3, which is?
9.
9.
Keep larger number as your max. 6 or 9, which one will I keep?
9.
9. 9 now.
Okay, now I am go to step 3. Read the next number in the list, 13, right? Compare your max. My max is 9. And the number in step 3 is now 13, right? This changed. Keep larger number as your max, 13. Go to step 3. Step 3 is reading the next number, 67, right? Let's change that. Compare your max. My max was 13 now. And the number in step 3 is 67, right? Keep larger number as your max. Go to step 3. Read the next number in the list, 3, right? Now we will see whether it's gonna work. Compare your max. My max is 67. The number in step 3 is now 3, right? So which one will I keep? Will I change the max?
No.
I shouldn't.
I will go to step 3 again. I'm done with here. I didn't change. My max is 67. Now I'm gonna come to 48. Read the number 48. Is 48 larger than my max, 67? No. I'm not gonna change 67, go to step 3 again, read the next number 12, compare. So this will work, okay? When it comes to the end. So when you first say, when you are going through these numbers, you told me you are eliminating the smaller number from your memory, and you are keeping going by keeping the maximum. So you are comparing 5 and 6, keep 6, 6 and 9. You are doing it binary. You have to do, your brain is also doing it binary. 6 and 9, keep 9. So there is an idea of keeping one number in your memory, and that is the maximum number. And you are comparing with the new number, and then you are changing that. If the number is larger, you are changing your current max in your brain. Okay? So this is one algorithm. We are keeping one number in the memory and comparing the new numbers to that current number in the brain. So when I say in the brain, it will come in our case, we're gonna open a space in our brain for a number called maximum. I'm like, the brain is processing that and placing, like, do you see, you are not keeping 5, for instance, in the memory. You are deleting that from your memory, actually, to take a new number. Computer will exactly do the same thing. Okay? Now, how will you, for instance, let's say you have a phone book. By the way, you never saw phone books, right? Do you see hard copy phone books before?
No.
My parents have, but we don't have a job.
Okay. This is the phone book. I saw this, they were using them. And yeah, you don't know anything about phone books. And I'm asking whether Mike Smith is in the phone book. Now think about this also. This is basic, like we do these things from our, like since the childhood. So you are used to automatically doing stuff. But how will you look to the, like, how will you open this? Let's say this book is closed. How will you look for Mike? What will you do?
And we will look for the letter M. at
Yeah,
first.
the alphabetical.
What if there is no letters on the side of the book? Like, how will you look for letter M? Do you see what I'm saying? Like, you're going to open the book, right? And look to what?
I checked the alphabetic list.
Yeah, but try more primitive. Like when you open the book, what will be the first thing that you are looking? You open the book and you're going to see what?
Names and numbers.
Okay, names and numbers. How will you move in the book? That is what I'm asking.
Hocam, we will look ingredients, maybe.
What does that mean?
We will look to this book, what this book contain.
Okay, that is great. It's a phone book and there are names and numbers. Okay.
Yeah.
And I open like any random page, let's say.
Okay.
What will you check?
I checked the first letter.
Okay, what is the first letter?
M.
Yeah.
By luck, you open immediately. Your random page is Mike. So what if it is your random letter, the page you open is on the letter C? What will you do next?
We will go to like the alphabet M.
Yes, until M, I'll keep doing this.
You're gonna turn, go to the right of the book, right? If you are at the C letter. If you open by luck the letter P, for instance, if you're on page with the names with P, you will go to the left-hand side, right? Because you know M is before P. So you will do that. If you try to describe this to a person, how would you, this is the difficult part. How will you help them? Like try to come up with an algorithm to find Mike Smith in this phone book. How will you describe to them? Will you say open a random page?
Check the first letter of the name that you are searching, we can say.
Okay, so the first step is
Open
open
up a page.
random page.
Mhm.
Then describe it like we were doing with the maximum number case. If the letter in the random page starts with a letter smaller than M, right? Then
Keep next one. Go through.
so
Go to the right.
what you are doing is scanning, right? Try to come up with a, like, let me tell you this, there is also efficiency in the algorithms, okay? We are trying to come up with the fastest algorithm. So if you just go one page by page, it will be a slow process, right?
Can we say hocam keep scanning until M?
Then if he opens the first page by luck in the letter A, it's gonna go through the whole book almost, right? Do you see my point?
Mhm.
Can you come up with a faster solution? Instead of like right now, I'm also trying to come up with your cases, like instead of page by page, maybe you can say go 10 pages to the right. Does it make sense? So open, this is our second algorithm. Let's say open a random page. If the letter on that page is smaller than M,
Mhm.
right? Go 10 pages more to the right of the book. When I say right, yeah. So then you're gonna say what? Now he came 10 pages forward. What will they do now?
Hocam we say 10 pages forward, but if you pass the M, what
Yeah.
will it do?
Okay, you need to describe that also.
We can say like see the alphabet that it's in this page, in the current page.
Okay, now you are saying, do you see, like you are again comparing, just like the maximum number case. Now we're gonna say, come 10 pages forward, check the letter in that page. If the letter is smaller than Mike, go 10 pages more. Does it make sense? Is that correct? You want to go page by page. You are thinking that is the most efficient one.
Yes, hocam, because I'm not sure that I'm gonna find in 10 pages or not.
Okay, so let's write that. Open a random page. That is our first step, right?
Mhm.
Next, compare letter in that page to M, right? We are going with the first names. So what is the next step? If
The letter smaller than
yeah.
M.
if the letter is smaller than M, go 10 pages forward. I'm not saying single page. But if it is larger than M,
Back 10 pages.
Return
Go
10
10 pages backwards.
Go 10 pages back.
so this is, let's not put that. If the letter is larger than M, go 10 pages back.
But hocam, if I go 10 pages back, I'm starting to, I'm turning back the initial point.
Are you ready? Okay. Now let's read this. These are our primitive algorithms, but that is fine. I open the random page and I compare the letter in that page to M. Okay.
Mhm.
Let's say the letter is C. Okay. Is C smaller than M?
Yes.
So what will happen?
10 pages forward.
They're gonna go 10 pages forward. Did I come to here? Yeah. If the letter is C larger than M,
Mhm.
is C larger than M?
No.
So will this be executed? No, because it's gonna do this if, let me put it this way. Okay, so
Mhm.
they're gonna go backwards if the letter is larger than M. So right now with the letter C, I am 10 pages forward. What will happen next? Now I came to 10 pages forward. I'm not at C anymore. But what should I say to the person? Now I came 10 pages forward. And again, I'm gonna, let me put steps here. Okay, and I came to here. I didn't execute this line. I'm at the end. Now, I need to come back to step 2, right? What is the letter in the new page now? There is a new letter, right? They're gonna compare if the letter is smaller than M, they're gonna go 10 pages forward. If the letter is now larger than M, they're gonna go 10 pages backward. Here, what we are doing is moving by 10 pages, right? Instead of just through searching the whole book. And maybe there are more efficient ways. You are right. Then we might not, according to this algorithm, we might miss the M might page, right? Because we are moving 10 pages at one step. But when we move one page, that is also not efficient. You are sort of going through the whole phone book. So can you think of any other algorithm?
Hocam, can we say check first letter until M?
What
In
does
every
it mean,
page.
Wahab?
In every page.
But you don't want to, like, that is what I'm saying. If the person opens, you are not telling me, like, we are picking a random page, right? In the beginning. What if that random page, think it like you are doing it with your closed eyes, okay? That is what random means.
Okay.
So you need to say something about, it shouldn't be random. That is what I'm trying to say. When we say open a random page, they are blindfold. They can open the first letter, like they can open A even. Then you're gonna go through all single pages till M.
Mhm.
So we need to, that is what I'm trying to show you in terms of efficiency. We need to solve this problem with smallest number of steps. And by the way, this should not only work for Mike, it should work with anybody.
Maybe we can eliminate the letters like A, E, O.
How will you do that? This is all
I don't
about
know.
giving recipes, right? So right now you are thinking abstract, okay, but you need to tell me what to do. That is what I'm trying to say. Tell me what to do then. Like, how can I do that? What you are saying.
Keep bigger letter. It's just like the first example.
Okay, but what is the first step here? I have the book. What should I do?
Hocam, keep first and next paper and keep bigger one.
So you are saying I'm gonna scan it 10 page by 10 page from the beginning of the
Yes.
book. Is that really efficient? Will you do that? If you are in a
No.
panic, will you just go through every 10 pages? The issue is here, like, there are two problems in this, the algorithm that we did. If we go 10 pages at each time, we might miss, we will never reach to Mike. That is one issue. The bandwidth, let's say, the 10 pages is too much maybe. The other issue is opening the random page. You have something in your head actually about the letter M, right? You can think of like whether it will be the half of the book, whether it will be after the half of the book. But for that, you need to know the frequency of the, like for instance, in Turkish, we have many letter K, let's say, the names which starts with K. But in a different language, we don't know the frequency, how many names will we have with K. So right now I'm adding, it will not only work for any, like it should work for any phone book in any language.
Okay.
Any other suggestions? Somebody was suggesting delete some, like getting rid of some letters. How will I do that?
But hocam, you say eliminate meaning is delete.
But the thing is, like, what I'm trying to give you the sense of thing is, like, you need to describe it to me. Like, that is the missing part. You need to tell me exactly what to do. That is an algorithm. Now, is there anybody who would just do it for Mike, for instance? Let me show you the algorithm. Pick up the phone book. Do you see, like, that is the first step. Open the middle of the phone book. That is, by the way, you can solve the problem with many different solutions. There is not a unique solution to problem, right? There might be many other solutions, but in the computer programming language, we will try to come up with the fastest and least, there are two issues. One of them is time, the other one is your memory. So it needs to be fast and it shouldn't consume that much memory. There are two things, okay? Now, open the middle of the book, look at names. By the way, they are going from the last name. We did it with the first name. If Smith is, that is the first thing. Like they are doing with the last name, they open the middle of the book. And if Smith is among names, call Mike, it says. So you try to find from the last name, try to see whether there is a Mike in that list. So you are at the correct page by chance, right? Not by chance the Mike is coming to the middle of the book. Else, if Smith is earlier in the book, that is the comparison. Now what they are doing is, okay, open to middle of the left half of the book. Let me see. Just a second. Now I have the example also. Okay, this is my book. And what are they saying? Open the middle of the book. I did open the middle of the book. If the name is in this page, I'm gonna call Mike, right? What are they suggesting in step 5? Görebiliyor musunuz? Ha? What is step 5?
If Smith is earlier in,
You are doing
in the
that
book.
comparison, right? Letter comparison. If I'm on the later page than Smith, then I'm gonna open to the middle of the left half of the book. So I'm gonna go to the left side of the book. And what I'm gonna do, I'm gonna look at to the left side of the book and exactly to the middle of that. Okay, do you see it? Like this is the half of the book. Now what they are telling to me, go to the left half of the book, right?
Mhm.
Now let's say I'm at 5 and I open the left half of the book. Go back to step 3. Look at names, right? Is Smith in this page? If so, I'm gonna I will be okay. If let's say I came to letter C now, instead of what I'm seeing in this page is letter C. So is Smith earlier in the book than C? I'm at the question here.
No.
Where will I go then? What will I do?
Right half of the book.
Right? Else, if Smith is, I know that Smith is later in the book. Now what will I do? According to the prescription. Open to the middle of the right half of the book. So at this point, my right half is here. Okay? Now what will I do? I will go exactly to the half of that right side of the book. Now what is the next step? I am at W. Okay? At this page now. Well, what will I do now? I'm at here, right? Go back to 3. Look at names. I'm at W. Is Smith among names in this page? No. I came to here. Is Smith earlier in the book?
Yes.
Now what will I do?
Again, the left half of the book.
Okay, that is one algorithm. It might not be the most efficient one, but it is a search algorithm. Okay?
Can I ask something? This may be not efficient if the surname is different. For example, if the surname is starting with letter A, then maybe it can be not efficient to open the middle of the phone book. So are we going to do the same thing for every case?
This is
Okay. We say that this is the most efficient way, so that we're applying the same for every case.
this is like efficiency is like you. This is a good question, but let's think about. Do you see my screen now? Yeah. Let me put 199 here. Okay, but 6 is here. Now I found my biggest number in my first hit actually, right? But I need to go
Yes.
over the whole list. If this 199 is at the end, then it is worth to going to the end of the list. But when 199 is in the beginning of the list, it is not actually worth, right? This is not efficient. I should have stopped there. But you don't know that from the beginning. The algorithm should work for any input. That was a good question because we need to show that. So the algorithm should be working for letter A, for S, or for whatever, okay? So
Okay.
efficiency is also for a single. But if somebody told us, for sure, I'm gonna give you the name starting with A, then you can come up with a different algorithm.
Okay.
Okay. Now that is what was saying. An algorithm can be executed with different inputs. It should wash different laundry correctly. In our first case, it should work with any letter in the alphabet for the phone book case. And the list finding the maximum number should work with any given input. That would be your mistake also. We are used to, like, when I also cannot solve a problem, I come up with an example. Okay, if I solve the problem with that example, I think my solution is okay. Don't make that mistake also. Okay, when you are writing programs, you're gonna come up with, like, as I said, your algorithm can be different than my algorithm, but check it with different inputs. Okay, because it might work with one input, but it may fail in the other input. So that is the danger in programming. You shouldn't always come up with one example. You should try to think in general. Okay, do you see what I'm saying? Like, maybe 0 is like this, you are looking for the smallest number, and 0 is at the end. When you look to the smallest number in this list, it is in the beginning. So if you try to write according to that, then your program might fail. And algorithms can terminate with an output. It should be finite. For example, with the 10-page case, when we were writing the 10-page, go 10 page forward, go 10 page backward, we might be in an infinite loop, okay? So there won't be any output in that case, because we're gonna, every time we move 10 steps, we can be passing mic, right? And we might not end up with a solution at the end. So that is the other danger. Let's do this tomorrow, like later. There is one more example. We're gonna do that, but later on. It will be too much for today. Program, however, is the realization of that algorithm in a specific programming language. So till now, we try to come up with the solutions. When we write those solutions, in the next step, we need to describe that in the computer language. By the way, when I say computer language, also that is not correct, because computer language is binary. It just understands zeros and ones. This is the middleman in between us and the computer, okay? There's a new language, and that language is called programming language. There are different programming languages. Here, this is in Python. And you will be able to writing stuff like this. Do you remember our code for the algorithm for the read the first number in the list, then set your max to the first number. That was the correct algorithm. Now, in the programming language, do you see? Read the first number, and your max will be the first number in that list. Then there is a loop which goes through all those numbers and compare that to your current max. You don't need to understand that. But right now, there is a human language, a recipe, and we are transforming that to the middleman, which is the programming language. Then that would be translated to the computer language, which is binary. So algorithm, programming language, and computer language. They are all different things. If you come up with the efficient, like if you come up with the correct algorithm, that is the major step actually in solving the rest of the problem. The rest is easier. So algorithms are recipe for problem solving. They should work for all inputs of the problem, must terminate in a finite number of steps. Granularity of the step recipe must be defined clearly. It depends on audience, programming language it is designed for. We're gonna see that. So you need to be specific with the steps. For instance, for the washing machine case, what if the clothes are cotton? Okay. What if the clothes are white? We didn't make any separation according to color, right? We will wash. If they are wool, we will wash with a program. If they are not wool, we will pick a different program. But will you wash whites and dark colors together? Wahab, will you wash white and dark colors together in the washing machine? No, you don't, okay? Because the colors get mixed up in the hot temperature. So our granularity was missing in that washing machine case. That algorithm might fail. your whites can come in a different color if you just select according to wool or not wool. So there was an issue in there about the how we define each step clearly. There might be, that is what I was saying, there might be more than one algorithm per problem. There is not a single solution to every problem, but we are trying to come up with the most efficient one. And efficiency is measured in time and memory usage. And there's always a trade-off in between them. Think it like that. Like when you are keeping something in your memory, you will become faster. Is it true? Or will you become slower? There is the trade-off means if it is faster, it is more memory consuming. If it is more like, do you see there is a, so time and memory are inversely related. So if you consume more memory, it will be faster. If it is slow, it will consume less memory. So we need to make that trade-off also. We're gonna see that too. For instance, when I say for the finding the maximum number in the list, when I say use more memory, how can you do that? Let's go back. What is the meaning of consuming more memory in this case? Can you come up with an example? This is one algorithm. If I want to consume, if I am okay consuming more memory, what could have I done? Instead of reading two numbers, I could have compared three numbers at once. Like I could go 3 by 3, 5, 6, 9. But then it becomes hard to keep that also in the memory, right? So it will become faster, but it becomes challenging for your brain, right? That is the deal with generally with the algorithms also. CPU, however, only understand machine language. As I said, it is either on or off. Electricity is on or off. So zeros or ones, and that is inconvenient for us. That is why if we could have written that program in the binary, we can do that. But since we can't, programming languages are found. They hide the complexity of the machine language, which is that binary form, provide more abstract constructs, and make programmer-machine interaction efficient. So as I say, algorithm, programming language, then the machine language. We cannot directly write in the machine language. And there are different programming languages. They are designed for different use cases. And some of them are procedural, some of them are object-oriented. They have certain advantages or disadvantages. When I say object-oriented, in the second half of this class, we're gonna go there also. It is all about how you structure the program. So as I said, proceed with the procedural programming. Before the first semester, I'm gonna finish the procedural part. Every language is procedural, okay? Python, C, C++, Fortran, Java, they all have some procedures. When I say procedures, those recipes will be translated. But object-oriented is about structuring the program. That is not in every language. For instance, C is not object-oriented, but C++ is object-oriented. And Python, the reason why we are picking Python, one of the reasons is most of the biological softwares, they are now written in Python. But the other thing is, that is the easiest programming language for the object orientation. That is why we're gonna go with Python. Guys, right now I'm gonna stop here. So this is a brief intro to the algorithms. We're gonna continue next Thursday from here. Tomorrow we will be in the class going back to the Linux. This is a little complicated, but I didn't like the lab 1, so let's do everything in lab 2. And that's it. Do you have any questions? I'm gonna put this to the YouTube channel again. Did you see the YouTube channel? Did you see the awkward videos there?
Mhm. Yes.
Biriniz konuşuyorsunuz ama şu an anlamıyorum.
Yes.
Biraz garip garip çekilmiş ama
Defne yes diyor hocam.
ne istiyor?
Yes diyor hocam Defne.
İyi, teşekkür ederim. Vahap iyice çok fazla yardımcı olmaya başladı şimdi. Okay, guys. So, all the lectures will be there. Sometimes it takes a while to upload them, but like right now I can do this one. It will be probably short. And tomorrow we will get a better setting in terms of the camera, seeing at least the board. Sometimes it is seeing strange places. Okay. I'm gonna go then.
Thank you hocam. See you.
Thank you. Bye bye.
Tomorrow, guys. Bye bye.
See you. Bye
See you
bye.
hocam.